Hello everyone, this is Mohsen from the Ozen Engineering team. In this video I just want to show you that how we can define a cone angle as a parameter. This is something that is not easy to do this in when we have solid modeling, to use angle as a parameter in Discovery, and later I'll show you that I have to use it for parametric study for CFD simulation in Fluent. Please watch this video. Okay, in Discovery, let's start sketching cone. Before that, I just activate history tracking. Okay, let's start making cone. This is the first cone, and this is the second cone. And now let's define the dimensions. So the angle, this is 71.6, and second angle, so we define the angle. And now go for the faces. So you can see that here I have this two angle D1 and D2 that I can define them as a parameter, and you can have it here. You can see that instead of 71 I can make it 80 and rerun. You can see that it's changed. I can define the second angle for the second cone also as another parameter. Instead of 60, put it 55, for example. So here you can see that by using history tracking, I can define these parameters for the angle for these two angles. Let's now go for using the pull and revolve and define these two as two cones. So this is one cone, this is second cone. You can see that even at the 3D cases also I can change the angle. For example, this one I can rerun history track, it is changed. And this one I can make it like a 70 and run it. So in this way I can change the angle of the cones. It is 40, it should be 50. Okay, I can change the angle of the cone as a parameter. Let's just save it. Okay, before going to a Workbench for performing next steps, I can define this like this is like an inlet and other faces on the other side, okay, as outlet. So we have inlet, we have outlets. Okay, now I can again save it and go for Workbench. You can see that we have these parametric sets, okay, for P1 and P2 with the original values that I have, and this is from the geometry. So these are in the input parameters. Now I can go for a CFD modeling add Fluent with meshing and go for the meshing. Okay, double precision, say that 8 and start Fluent meshing. Import geometry. Okay, this is the geometry. This is what we have it. The two cones that we have that here. So I'll do just quickly the steps for the for meshing. I just go by the default setup. No local sizing, default sizes for max min for the surface mesh. Only fluid. Change internal walls to the internal walls to internal. I didn't do the share topology in Discovery. I do it here and go for that. Apply share topology. Boundaries, inlet, outlets. Okay, all right. Just one fluid region. I don't go for boundary layer here. I just want to quickly mesh it. So the last step is volume meshing. That's I use polyhedral mesh for the meshing. So you can see that this is the mesh. I can save the project and go for next step. Now in the Fluent. So before starting Fluent, let's just review again parameters. We just have input parameters, two angles, cone angles from the geometry, no output parameters. So I'm going to define output parameters after setting up the model in Fluent. Reading the model and uploading the data for geometry and for mesh. Okay, this is the model as you can see here that we have it, inlets, outlets. Let's go directly to set up the geometry, the out boundary conditions. Velocity boundary condition, say that 5 meter per second, no, say that 1 meter per second at the inlet. Apply. Outlet, it is pressure outlet, we just keep it as is, 0 gauge pressure at the outlet. And we can initialize the model, initialize it. For before running, for output parameter, you can see that this is output parameter. I'll go with, say that velocity at the outlet, so I call it outlet velocity and check mark here that it is output parameter. can compute that. You can see that. Okay, and we can start now solving. Okay, we need to say that 100 iterations. Start solution. So assume that we have converged solution. We can save the Fluent model and the project, Workbench project, and now go back to Workbench. First of all, now you can see that we have inputs going from geometry to the CFD model and coming back here. So if I check the parametric, the parameter parts, now I have the output parameter, which is just velocity at the outlet. You can see that here, and I have the initial value for that, for the initial values for the input parameters, for the two parameter P1 and P2, which are the cone angles. Okay, let's start parameterization. Say that, okay, keep this angle as is, but change this to like a 70. Okay, and see what's happened. So say that, okay, update the selected design point. As you can see that it is DP0, the first design point. DP1, it is the new sets and new setup parameter. Okay, okay. We can see the progress here, the progression. It says that updating the geometry, so changing the cone angle for the second cone from 50 to 60. So now it is updating the geometry in Discovery. Updating the mesh. And now starting Fluent. Now Fluent is uploading the new mesh. Okay, updating Fluent setup. So it is updating the Fluent model. Now solving the model. We almost done. Okay, this is the new geometry. Let me close that one. Okay, you can see that by changing the angle of the second cone from 50 degree to 60 degree, how much is the velocity changes. I can repeat this with say that like a larger angle here for the first cone. Okay, and see that now how much velocity here compared to the original value. Update only the selected data point, which is now data point 2, and solving. So we repeat the all steps for uh, this simulation, starting from updating the geometry, updating the mesh, and then updating the setup, and at the end solving the kind of new model. So starting Fluent, updating the mesh, updating Fluent setup, and then last step is solving the model. Now it is solving. So all steps in the workflow will be repeated every time I have a new data point here. So you can see that, okay, when I increase the first angle from 70 to 80, how much this velocity changes at the outlet. So in this video I just showed you that how to use history tracking in Discovery to define the parameters based on the cone angle. I'm just opening Discovery to show you that, okay, these are the updated model, the new cone angles that we have. Okay, and this is all of that. It is based on using history tracking feature in Ansys Discovery. And after that I can just go for the parametric study and for Fluent simulation using Workbench. Thank you very much for watching this video.